If you're watching this video, it is because you completed the Canister Rocket Lab, and now you're trying to complete the post-lab. So this is the lab, you read it, we went outside, we shot those rockets off, and you're trying to do this part 4. So let me help you with that, I'll walk you through it. First though, let us understand. The goal of this is to use Newton's law, his equation for the force of gravity, to figure out how much gravity is there between two objects. You can calculate the amount of gravity, the force of gravity between the Earth and the Moon using this. So we are doing it with a rocket that you launched off. So we want to figure out not how much gravity there was or is between the Earth and the Moon, but how much gravity there is between your little your film canister rocket that you shot off and the Earth at its average distance. So just for fun, we did a couple of launches. Now first, let's talk about a few things. When we launched it, your rocket was sitting on the ground and it shot straight up in the sky or something like that. We used the side of the building to try to calculate how many meters high your rocket went, and we just estimated. We figured that each of these little slats is about a foot, so 3 of them is about a meter. We said that because 3.3 feet actually equals a meter, 1 meter. So we're just estimating here. So if your rocket launched up and went this high, you and your partner may have said 1, 2, 3, 4, 5, 6, 7, 8, 9. It went 9 slats high. That's 9 feet. So how many meters is that? Well, we just divide by 3. We can forget about the 0.3 now. We're just estimating. And we'll say that your rocket went about 3 meters. So your first launch, you wrote about 3 meters. And then you did it again. Let's say it went about 4 meters high. Let's say it went 2 meters high. Then we'll say it went about 4 meters high again. So now we are going to figure out the average height. Because for this equation, as you can see, we can calculate the force of gravity between the Earth and your rocket at a certain height. Since we did multiple launches, we're just going to average them together so we can get one height, unless you really want to calculate it for every single launch you did, which we don't have to do. We'll just average them together. So to average it together, the first thing you have to do is add them. That is the sum. 4 plus 2 is 5, 6, 7, 8, 9, 10, 11, 12, 13. Now notice first that your height is going to be different. These are just my numbers. Okay, so yours are different. I'm just showing you how to do it. So to get the average, we have to add all of them up and then divide by the total number of trials. So divide it by 4. And that will give us, if we use a calculator, 3.25 meters is your average. So go back to the pen, 3.25 meters. So let's use just that average when we calculate how much gravity there is between the Earth and your canister. We'll do it at that height. So what this next part, the part 4, does is it pretty much just wants you to write out all of the components of this equation. So the first question says, what is the equation? Well, it's right here. So you can pause this video and write that down. I'm not going to write it down just to save time. Okay. Then it says, what is the value of g? The g constant, it is a constant, it's always the same. It is this, 6.7 times 10 to the negative 11. Okay, so write that down. You can pause the video. Then it says, what is the mass of the film canister? I actually took the mass and we found out that it's 8 grams, or, because it has to be in kilograms, 8 times 10 to the third kilograms, or 0.008 kilograms. So these parts, these are going to be the same for everybody because the G constant is always the same, the mass of the Earth is always the same, and the mass of our canisters we can assume are all the same. They're all the same canister. The only thing that's going to be different is this R, and the R is the distance that your canister went. So for my canister, my numbers, it's going to be 3.25. So you wrote out the equation, you wrote out the G constant, you wrote the mass of the canister, the mass of the Earth, and then you're going to write down your own personal number. This is going to be different for everybody else. That's the average distance that your rocket went. So now what you're going to do is you're going to plug that all in. I have all the numbers here, so let me show you what the equation would look like. All right, I'm using my mouse to write, so it's a little sloppy, but the equation, this equation, if you plug everything in, is going to be 6.7 times 10 to the negative 11th. That's the G. The mass of the Earth is 5.97 times 10 to the 24th. And the mass of the rocket is 8 times 10 to the negative third. Now, the only part that's going to be different is the R. But here's the tricky part. A lot of people forget this. The value of R is the distance from the center of the Earth to the center of our rocket in this case. So we know that the rocket, in my case, went 3.25 meters high, but we have to add to that the radius or half of the distance of the Earth for the total distance between the center of the masses. So let's do that. This is the radius of the Earth. It's 637,100 6,371,071.03 meters. So I'm just going to add my number, my 3.5 to that, plus 3.5 equals, and I'll find the answer. That is 6,371,074.53 meters. Okay, so that is what the R is going to be. It is going to be this number plus your height from your paper, your average height. And that's what goes on the bottom here, except look, it has to be squared. So we will square that. So let me clean this up and show you what it looks like. Actually, I could do it real quick. These numbers on the top are the same for everybody. So if we actually multiply those together, I plugged it in, we get this, 3.19992 times 10 to the 12th. So let me fix that here. So everyone's top number on this equation is the same. It's G times the mass of the Earth times the mass of the canister. Excuse me. That equals 3.19992 times 10 to the 12th, as I did here. And now we have to divide that by the distance between the canister and the center of the Earth. But first we have to square that number. So I will plug that in and square it. When I square that, I get this number. Now that's my number because I added my average height of the rocket to it. Yours might be a little bit different. Now I'm going to just write that under here. Okay, and so I wrote it down there. Now these are big numbers, but honestly, it's not really that hard. You just kind of plug everything in. So then everyone's equation should have the same top. Your bottom should be a little different than this. And then we just have to plug that in. So I'm going to take this number here. Now I'm just going to put divided by my total number, which was that. And then we'll hit enter. Boom. And what did I get? I got 0.00078. I'll just round that to 0.0079. Put that here. That equals 0.00789. I rounded newtons. And that is my final answer. You could change that to scientific notation if you know how to. 1, 2, 3. We could say my answer is 7.89 times 10 to the negative third newtons. All right. If your answer is much different than this, come talk to me. Now for the rest of this worksheet, if you're wondering about the bottom part here, let me get rid of all this stuff. There we go. If you're worried about the bottom part, all I want to do is revisit what Newton's laws are. Right? The first law, second and third are up here. First one says that an object at rest will stay at rest until it's acted on by an outside force. I just want you to look through the lab. Think about what we did. You can actually even take sentences directly from the lab and write them here, but I want you to show me what part of the lab actually exemplifies the first law. I'll help you with this one. I'll give you a hint. The first law says that An object will stay at rest. If it is at rest, it will stay at rest until it's acted on by an external force. Let's just think about what we did in this lab, right? Your rocket down here was sitting at rest on the ground. It wasn't moving. So it's going to tend to stay at rest unless an outside force acts on it. Our rockets shot up in the sky. What outside force made that happen? Think about that. That's your hint. And that's also the answer for the law one. So just go through the lab and think about what we did and double check the laws, of course. What part of the lab represents law one? What part of the lab represents law two? What part of the lab represents law three? Just ask if you have any questions.